All devices on an IPv4 network need a 32-bit logical address in order to communicate. This 32-bit logical IPv4 host address consists of a network portion or network ID on the left and a host portion or host ID on the right. The length of these depends on the size of the network. Larger networks will have a longer host portion. A network can be thought of as a range of addresses. All devices on the same network have the same bit pattern for their network ID, but they will have a different host ID. Some addresses in this range are reserved and have a special name and meaning. For example, the first address in the range is used to identify the network itself and cannot be assigned to any host. It is referred to as the network address. The last in the range is called the broadcast address and is used to send a message to all devices on the network at once. It also cannot be assigned to any host. All the IP addresses between the network and the broadcast addresses make up the usable or valid host range and can be used to address the hosts on the network. Let's take a look at how these addresses are determined. In order to forward data, a device needs to know what network it's on. Using their host IP address, their subnet mask, and a process called binary ANDing, a device can find what's referred to as the network address. This address represents the network to which the host belongs and will be slightly different than its host IP. To do this, the device compares their host IP and their subnet mask bit for bit. If the bit values are both a binary 1, the result is a binary 1. If one or both of the bit values is 0, the result is a binary 0. Let's take a look at an example. Let's say we have a PC with a host IP address and a subnet mask of 192.168.2.38/24, and we'll use ANDing to find the network address of the host. Here's the host IP in binary. Here's the subnet mask in binary. If we compare them bit for bit, we can see that a 1 and a 1 results in a 1 and a 1 results in a 1, a 0 and a 1 results in a 0 and a 1 results in a 0, and so on until we have compared all 32 bits. Notice that the last octet is all binary zeros. Because we are using a /24 subnet mask, the first 3 octets represent the network portion and the last octet is the host portion. Network addresses will always have binary zeros in their entire host portion, however long it is. In this case, the last 8 bits. If we convert to dotted decimal, we can see that this host belongs to the network 192.168.2.0/24. Now let's determine the broadcast address for this network, which is used to send a message to all devices on the network at once. Whereas the network address had all binary zeros in the host portion, the broadcast address will have all binary 1s. Since the host portion in this example is just the last octet, to determine the broadcast address, we keep the network portion the same and change the host portion to all binary 1s. This results in a broadcast address of 192.168.2.255. Next, we'll determine the usable host addresses, which lie between the network and the broadcast addresses. The first usable host in binary will be all binary zeros with a binary 1 at the end of the host portion. Converting to dotted decimal, this tells us the first usable host on this network is 192.168.2.1. Lastly, we'll determine the last usable host, which will be all binary 1s with a 0 at the end, the opposite bit pattern of the first usable host. Converting to dotted decimal, we get 192.168.2.254. Let's recap our calculations. We began with the host IP address of 192.168.2.38/24. Using binary ANDing, we determined that this host belongs to the network 192.168.2.0. Keeping the network portion the same, but placing all binary 1s in the host portion, we determined that the broadcast address for this network is 192.168.2.255. Again, keeping the network portion the same but changing the host portion, we determined that the usable host range for assigning addresses to devices on this network is 192.168.2.1, which is one number up from the network address, and 192.168.2.254, which is one number down from the broadcast address. You can see that our original host IP address falls within this range. Things to keep in mind when working with IPv4 addresses. All IPv4 host addresses are 32 bits in length. A portion of the address represents the network that the host belongs to, and that starts at the left. The remaining part is the host portion, which identifies the host on the network. And there are two special reserved addresses on every network that can't be assigned to hosts. One is the network address, which is the lowest in the range of addresses and represents the network that all the devices belong to. And the other is the broadcast address, which is the highest address in the range and can be used for a shout out to all devices on the network at once. Thankfully, there are shortcuts you can take for calculating these addresses without having to convert to binary first. But examining these addresses at the bit level should help you understand how network devices interpret them and also how the dotted decimal format is derived.